Thank you all for joining my session, and I hope you are enjoying the event so far. So, fake news. Fake news is considered as one of the most serious problems facing the international communities due to its negative impact on both individuals and society. And if you think that fake news is a new phenomenon, you are wrong. Fake news exists even during the World War I and II. For example, a claim saying that Germany was extracting glycerin out of dead soldiers was used to influence China to join the war. But fake news nowadays becomes a very serious problem due to social media platforms. They contain a huge amount of false claims created intentionally to manipulate public perception and mislead the readers. Despite the danger of fake news on social media, it has been reported that over 62% of US adults are getting news from social media rather than other news organizations, traditional news organizations. But fake news should not be confused with rumors, spams, or yellow journalism. Fake news has its own definition. It's a completely fabricated claim or story created with an intention to deceive, often for a secondary gain. The gain is usually financial or political. But there are many characteristics that can be used to identify fake news. Some of these characteristics are enabled by social media. So in addition to the text content itself, the source of the claim or the false claim, the profile of the user, and the way how these false claims get propagated on social media over time, and the relationship between users who share or publish these claims can all be used as characteristics to identify whether a claim is true or false. The data science community is working really hard to build artificial intelligence system to automate fake news detection. There are many machine learning models that have been studied or proposed in order to combat or to address the problem of fake news. These machine learning models are classified based on the features extraction technique and the model construction approaches. Fake news features can be extracted from the news content or from the social media content. Fake news is likely to contain inflammatory language, misleading headlines, and negative words. And there are many natural language processing techniques that can be used to extract linguistic features like the type of the vocabulary used, anomalies in the phrase structures, and the writing style. For example, the news like you can't believe what happened, or the results are shocking. This kind of structure, NLP is able to detect. Other features are extracted from social media, including the publisher profile, the user's opinion, for example, by counting the number of likes and dislikes on Facebook or other platforms, or by doing sentiment analysis on the user's opinion, their comments, and their feedback about a published claim. Also, other features can be extracted from the friendship and the propagation networks. All these features can be used to build machine learning models or train them to predict the validity of a claim. We can train or build news context models or social context models. We can train a machine learning model for fact-checking. This model will assign a truth label, 0 or 1, to a claim to say if it's true or false. However, fact-checking systems or machine learning models, they are somehow limited in terms of prediction accuracy, and they often require a second check by a human expert. But we can still use machine learning models as a building block or components that we can plug into a whole system for detecting fake news. We can use machine learning to train or to extract misleading headlines known by clickbaits, or we can predict the validity of the claim based on the stance of what other organizations are saying about the topic or the claim itself. Machine learning models are very sophisticated to detect non-human accounts on social media, like trolls and social bots. And finally, we can use machine learning to extract fake news propagation patterns by tracking their trajectory and their propagation over time and the relationship between users who share this type of false claims. So I will focus on the stance-based fake news detection models, and later on I will give an example and details on how to build machine learning models based on propagation networks. The intuitive way to detect whether a claim is true or false is by looking at what other news organizations are saying about the topic or the claim. So we want to train a machine learning classifier that will predict whether articles published by different news organizations agree, disagree, or neutral about the claim. So not all the news organizations are have the same credibility or like have the same orientation, so we want to rank them first. But we believe that by automating the process of stance detection, we can use this model to plug into a system or a pipeline system for detecting fake news. So our stance-based fake news detection pipeline can be implemented like this. So given a tweet, for example, we start by developing a search engine that will collect a set of relevant articles published by different news organizations, either by accessing some dedicated databases or from the web. The collected articles should be ranked based on the credibility of the source. So we will assign a weight to each article, and we will run them through our stance detection machine learning model in order to detect the stance of the article regarding the original claim. Then we will do a weighted sum of the different generated stances, and the dominant stance, or the stance with the highest score, will determine the validity of the claim. So, for example, if most of the news organizations are or disagree about the claim, so there is a high probability that the claim is false. So our stance detection model relies mainly on the news content, so the text content of the claim. So it is built based on natural language processing. So let's see how we can use NLP to tackle stance detection. Given two news articles, how can the machine tell these two articles share the same opinion? They have the same stance. Human language is very ambiguous, and sometimes words in different contexts may have completely different meanings. So we can say that if two articles agree, they are somehow similar in terms of content. NLP will help the machine detect the similarity by combining these four components: word, semantic, context, and topic. So NLP is all about extracting discriminative features that will help the machine detect the stance. To extract these features, I will go through a few techniques, some technical stuff about how to extract these features. So we first start by doing some text pre-processing stuff. The most important feature to detect the stance of two articles is the topic. Do they talk about the same topic. Finally, we want to understand the semantic meaning of the article, the context. So we will use some word representation techniques to represent the article or the claim. So first, we have to do some pre-processing stuff on the collected articles by cleaning the text, applying some tokenization stuff, then removing stop words, identifying the vocabulary. Once we have a set of clean articles, we need to represent them into a numeric format. We call this step vectorization. So we have a different numeric representation of text. We can use the document term frequency matrix. So this representation, based on we draw a matrix where the rows are the words in the vocabulary, and the columns are the words in the vocabulary, and the rows are the articles or document. Each row represents how many times each word appears in the document. You will see this representation is very important to extract the topic. The second representation is one-hot vector. So we represent each word in the text with a vector of real numbers. The size of the vector is the size of the vocabulary. We put 1 in the index of the word and 0 elsewhere. The drawback of this one-hot vector is the fact that the vector is very large, is equal to the size of the vocab. So instead, we can represent each word in the document using a technique called word-to-vec. So this technique will map each word into lower dimensional vector with real numbers in a way that it will capture the semantic meaning. And the third representation, instead of representing each word in the document, we will represent the whole document, the whole article, as a doc2vec, as a low-dimensional vector of real numbers. And this also very useful after to build our propagation-based network. So, as I said, to detect the stance from two articles, to say whether the two articles agree or disagree, so we need to detect the topic, discover if they are talking about the same topic or not. One of the algorithms used for discovering topics from articles is LDA, latent Dirichlet allocation. LDA is an unsupervised learning algorithm. Means that we don't assign a label to each article with their relevant topic, but we let the model discover that. Also, there is another characteristic of LDA. It's a bag-of-word model. Means that the semantic meaning of words and the order of words are both ignored. The only information that LDA cares about is how many times each word appears in the document. So, to better understand how LDA works, first, LDA is based on the intuition that each document is a mixture of topics, and each topic uses a set of words frequently. So that's why LDA takes as input the term frequency matrix and the list of words in the vocabulary. So the only input feature to LDA is the word. It will assign a topic to each word in a way that our document is represented as a mixture of topics. Two parameters control LDA, the alpha and beta. Alpha is the topic distributions per document, and beta is the word distribution per topic. So the output will be a matrix representing the distribution of topics per document. Still confusing. Let's understand better. So LDA assumes that all our articles are talking about 3 topics. Let's say politics, economy, and sport. And each topic is represented by a list of words with a probability of that word to belong to that topic. LDA also assumes that any article is a mixture of topics. Let's say 50% politics, 30% economy, 20% sport. And it will try to generate a document based on these two probability distributions. The generated topic generated document, may not have any meaning. That's why it is a bag of word model. But when we feed LDA our collected training text or set of articles, it will try to recalculate these two probability distributions by applying some probability rules, like Bayesian rules, and we'll try to recalculate the word distribution per topic and the topic distribution per document. So if we represent each news articles, using LDA, we will get a distribution, probability distribution over topics. So the goal here is not to find what is the dominant topic, but we want to represent each article with a pattern of LDA topics. So a unique pattern that when we save these probabilities in a vector, we can calculate the similarity between the two articles using the similarity between the two vectors. For example, by using the distance, the cosine distance. So this similarity will tell us whether these two articles are sharing the same topic, are talking about the same thing. So once we have discovered the topic from our news articles, we need to insert or understand the semantic meaning or the context, because LDA does not have any information about what is the meaning of the text. To do that, there's so many NLP techniques. We will go through the word representation technique. So with word representation, we want to map each word in our articles, or we want to represent each word in our articles by a vector of low-dimensional vector of real numbers in a way that words that are semantically related or similar should have similar vectors. This vector representation is called embedding. For example, the two words cat and kitten both have the same meaning. So we want their embeddings or word representation to be similar. The similarity here is calculated in the vector space. So in another word, if we map our embeddings or vectors in two-dimensional space, we want that words that semantically related or have the same meaning are mapped close to each other. So here, all the animals are mapped together or grouped together. People grouped together, like also fruits are grouped together. So the similarity between these words is calculated by measuring the similarity in vector space, the Euclidean distance. Okay. One of the algorithms used for word embedding is word2vec. It's an algorithm developed by Google. So word2vec will try to learn an embedding or a vector representation for each word in our text. Word2vec is based on the idea of context. So if two words appear in the same context, they are somehow related in terms of meaning or semantic meaning. For that, Word2vec will build a machine learning model that, given a word, I will predict the context. So instead of here saying, instead of cat, if I represented or I replace cat by kitten, the model will try to predict the same context. So the two words will have similar word representation, will have similar embeddings. There are two versions of word2vec. One is the continuous bag of words, and the other is the skip-gram model. So the skip-gram algorithm is based on 4 steps. So the first one, the first step, we should collect a large corpus of text. We randomly initialize each word in the text with a vector, random vector of real numbers. And then we need to set up our prediction task. So for each word, we pick a word in the context and consider it as our target or label. So this way we will set up our supervised learning problem, but the goal is this supervised learning problem is not to do well in this prediction task, but to learn the embeddings of words. So skip-gram is based on the neural network. It's based on a single layer softmax neural network. It takes as input our embedding, feed it to our softmax layer start by calculating the, multiplying the embedding by the weight at the bias, and then we want to calculate the probability of each word to be in the context of the word cat, for example. The output layer has the size of the vocabulary. So we want to predict each word in the vocabulary, what is the probability to be in the context of the word cat. When we compare the predicted target with the real target, we will come up with some loss. And during the optimization of this single layer softmax neural network, the model will not only update the weight and the bias, but we will update also the embedding of our words. So if we have here, instead of the word cat, the word kitten, the model is predicting the same target, then cat and kitten will both have similar embeddings. TensorFlow has provided the visualization tool to visualize embeddings. So I tried to search what is the nearest words to the word election. Here I can see, if you can see with me, there is presidential, candidate, where is it? There. Yeah, candidate, Democrats, democratic, liberals. So all the words that are semantically rated or happen to be in the same context are mapped very close to each other. In this way, when we use word2vec to represent our news articles, we will somehow represent each word in a way that we will capture the semantic meaning. So once we have collected our set of features, we want to train our machine learning model for stance detection. The machine learning model for stance detection is based on deep neural network. So first we want to extract features from our claim, features from our validation source, and some joint features. So the claim feature and validation features are the word representation, LDA, can do also the doc2vec, and then we want to calculate some similarity between these two set of features by calculating the distance, for example, of LDA representation and the word representation, or also by calculating the number of words appearing in both articles. We combine this set of features and feed them to a deep neural network with many hidden layers. The activation function of this neural network is the rectified linear unit, and the output is the softmax layer that will generate the probability whether the claim and the source agree, disagree, or neutral. So once we have our stance detection model, we can plug into our fake news detection pipeline and yeah, we are good to go for a fake news detection system. But there is something with this model. It is based only on the text content of our news claims or news articles. But to detect fake news on social media, we should also take into consideration other characteristics, which are the profile of the user who published the claim and the propagation pattern of the claim over time. So let's see how we can detect fake news on social media using or combining the three characteristics. Many works have focused their effort to build machine learning models for detecting fake news by combining the three characteristics of fake news on social media. One of them is published by Roshinsky, Shaw, and Liu. They proposed a hybrid deep model for fake news. This model is based on three submodels. The first one aims to capture the temporal engagement or the pattern of the temporal engagement of users with an article. So in another word, let's take an example on Twitter. Once a claim is published on Twitter, we want to capture the propagation process and the opinion of all users about the claim. So we will track all the users who retweeted the claim, what did they say, and the time. So in another word, we want to capture the propagation pattern of this claim on social media. We believe that the propagation pattern of false claims and the users responsible for sharing it, they have a common characteristics or common orientation. And the pattern of true claims is different. So to capture these two types of patterns, we use a recurrent neural network. Is a type of network that is very useful for sequence modeling and for capturing the temporal variations of a process or propagation process. So we will, at each time step, we will feed our recurrent neural network with a vector xt. This vector will contain 3 or 4 types of features. N is the number of engagements at time t. Delta t is the time between the engagement. XU is a vector representing the user's information: name, age, demographic, number of followers, followees. Also, we want to capture information about what did they say, they retweet. So we will represent their retweet or text using some natural language processing techniques, for example, doc2vec. So we will represent the whole retweet or the opinion using doc2vec representation. So at each time step, we will feed our recurrent neural network with xt that will do some calculations and generate a vector, a low-dimensional vector that represents the temporal engagement of users with the original published article. So this vector somehow represented the propagation pattern of the claim over time that will be used to detect whether the claim is true or false. The second model aims to identify malicious users or group of users responsible for sharing or publishing false claims. So we assume that users who share false claims, they have common characteristics. So to capture this characteristic, we start by drawing a user engagement graph. The edge between each two users is the number of articles they both engaged with. Then we want to assign a score to each user.
to each user. Sorry. To get this score, we first take this graph and save it into an adjacency matrix. The matrix will be very big because the rows and the columns are both represents the users, and each row represents how many articles two users have engaged with. So we want to minimize or reduce the dimensionality of each row in the matrix. We will apply some technique like SPD, singular value decomposition, in order to represent each users in our agency matrix with a lower dimensional vector. To calculate the score using this user vector, we use neural networks. So we will feed our user vector into a neural network that will extract high-level features from the original user features from our user engagement graph. To calculate the score of each user, we will feed the user feature to another neural network here that will generate a score vector. The size of this vector is equal to the number of users that we are tracking. So each unit represents a score for this user or for one of the users. We also want to get a per article score. To calculate that, we feed this score vector to a mask vector that will only extract the users who interacted with our specific article. We then do an average sum of the scores to get a per article score. Here. So once we have already extracted our propagation pattern and extracted the user score and article score, we can combine them and feed them to another machine learning model based here. For this example, it's based on neural network too, but we can use other techniques for that. And then these features, we will be doing some processing to detect whether the claim is true or false. Okay. So we have seen how to try to detect fake news using the news content, the textual content. And we also try to see how to use machine learning to detect propagation patterns to identify the validity of the claim. But fake news detection is still a very difficult task. And there are many challenges that data scientists are facing. The most difficult things is how to collect data and label them. The data on social media is very noisy and unlabeled, which make it very difficult for data scientists to train machine learning models that are very general and can be deployed on real life or deployed on one of our social media platforms. But we believe that machine learning is very promising for automating fake news detection, and I hope we can one day come up with the best solution for combating fake news. Okay, thank you so much. So if you have any question about, yes?
How you train the news article?
For which one?
For the news article, the fake news articles. You have a model, right?
This one?
No, this one, the first one.
For the stance detection, the stance detection fake news model. Yeah. So the data are generated by or published by the Fake News Challenge, is a competition for detecting fake news. So they have published something around 1 gigabyte of data
to detect the stance, and the whole pipeline is up to you to use it. But there is some dedicated databases for example, for the search engine. Let me go back to this one. So for the stance detection, you can get the data from the Fake News Challenge website. For the search engine, there's some dedicated databases. I don't know, the open data doesn't allow me, but it's not open source. But I can tell you, is, for example, Event Registry. They have a very big set of news, and you can just throw your keywords, and you will get all the news articles published by different news organizations, like using your keywords. For the stance detection, like they claim they reached like 90% accuracy, but the drawback is when you deploy it on real life on social media like data, the results get get very down, so it's not the same as 90%. Yeah. So yeah. So, but this one is, as I say, the drawback of this model is based only on the text content. If you deploy it on social media, you're still missing some other information that can be very helpful to detect whether the claim is false or not.
You may have, I don't know how you handle the challenge of Twitter, for example. There'll be only 1% of data which has fake. How do you answer the extract that 1%?
Of fake data? Yeah, so I got your point. So for this type of problem, the data that is fake is very in terms of amount, that we have less fake data than the true data. There is some machine learning techniques for handling unbalanced training data, and you have to be very careful on using what is the evaluation metrics in order to handle unbalanced training data. Because in Twitter, as you say, there is more like true claims than false claims. Yeah, so you will play on these two things, the unbalanced training data techniques and the evaluation metrics techniques.
Hi.
Oh, hi.
In your research, have you observed increased levels of sophistication over time by fake news publishers? So their content, some of the features that you're hunting for with your detection systems, that those are getting past safety nets, and if so, have you had to go back and re-optimize your models?
Okay, I should repeat the question. So you mean that if I get like a false prediction or something, do I go back and update the model?
No, the question is more, you have to have fake news publishers caught up on some of these techniques that you're using to make their fake news less likely to be detected.
Yeah, okay. So the profile of the user is important because we noticed that the relationship between user who publish like a fake claim, this user have common orientation. For example, the way how the fake claim get propagated over time is very quick when it is fake, and less the spreading time is different than when it is a normal claim or like true claim. So the propagation is over time is very indicative whether the claim is false or not. Also the user profile, the demographic, like about Russian, non-Russian, from where the claim is coming, can tell you like who is the user who is responsible for like spreading this type of information. Even like small information can be very indicative. How many followers follow it? What is the time that the claim get propagated? So yeah, so it's kind of combining different information together. Did I answer your question? Okay.
Yeah, to piggyback off of that, we able to, because of the, say, the short propagation time or other factors, detect chat bots. The other question I had was, back earlier when you were talking vocabulary, was that vocabulary pre-existing, or was that determined vocabulary?
That's a good question about the vocabulary. From the study, we noticed that false claims are generally trying to provoking the readers or mislead the readers. So they contain kind of specific vocabulary that is sometimes contains like a very large number of negative words. With NLP, we can classify. First, we take our training data, we label it as false or not, and then we'll try to detect the difference between the vocabulary used in the fake claims and the vocabulary used in the true claims. Also, I cannot deny that we need always to go to experts and have some help from them to look at the vocabulary and make sure that is more representative for fake news.
Does that vocabulary come from a source, or did you determine that?
Both. You can determine it manually, but also you can detect it from your training data. Yeah. Can you repeat the question?
Chatbot. Second question was detecting chatbot.
Yeah. So detecting chatbots will also help. You can use a component to detect chatbots and then plug it into a fake news system to use it as a feature or something to predict the claim or the validity of the claim. So it can be a building block, not as your whole system. So it's a subcomponent.
Identify behavior of a chatbot and say, oh, that's probably a chatbot, not a person.
Okay. For like trolls and social media social media bots. Yeah, it's using the profile of the user. The features are extracted mainly on the profile of the user and the relationship between users and the time that, what is the time or the number of times the user, the fake user, is publishing fake news. So, is a mixture of these three types of features to detect chatbot. Yes.
Very good talk.
Thank you.
Back to the basics of the terms themselves. When you were using the example of cat and kitten, and you talked about them both being felines and animals, but there are other contextual relationships. You could have parent-child, for example. So you could have different contexts, and I think of them in terms of different dimensions. Did you examine your data that way as well?
Yeah, so I didn't cover all the characteristics of word representation, but the technique word2vec capture the main characteristic of word2vec is that it captured the relationship between words. And if you look at the original paper, when they represented the word woman and the word man, and the word king and queen, they found that the distance between man and woman is exactly or almost the same as the distance between queen and king. Word2vec is very, very sophisticated in capturing the relationship between words. So also it will be able to capture the relationship between child and parent or child and man. So so if you go to word2vec, it's very, very sophisticated to capture the relationship between words. Yes? Sorry, I put this because the lights is okay.
At Viva, I'm not doing, at my actual job, I'm not doing fake news detection, but my work is basically natural language processing. I like looking at challenging problems and try to look how to solve them. So it was personal research work. Yeah.
So let's thank our speaker again.
Thank you.